Hey guys, can everyone hear me? Hi. Hey guys. Sorry that took so long. There's a few technical things I had to take care of, but I got everything set up now. Can someone in the chat confirm you hear me, please? Hi guys. Okay, so today we are going to be working on an experiment sometimes it's called sugar snake on the internet, sometimes it's called black snake, but we use baking soda and sucrose, table sugar, in this experiment, and it slowly builds and makes this snake that kind of grows upward. So we're going to be working on a few things here. Okay. We need sugar for this experiment. This is just normal table sugar. It's called sucrose. So it's a combination of glucose and fructose. And we'll talk about that in a little bit. We're going to use baking soda, chemical named sodium bicarbonate. And those are really the only two chemicals that we're using besides the lighter fluid to make everything burn. Okay. I've already prepared 2 different combinations of the sugar stuff. Okay, so I have regular sugar, and then I also have powdered sugar because I saw a demo that said it worked better with powdered sugar. So we're gonna try those, and in a second, we'll prepare our pots that I have sand in, and that is going to be our base of to where everything can work. Okay. So forgot the lighter fluid. I'll be right back. Okay, I'm back. I also have safety goggles because that's an important thing to be using here. And then the other thing that I have on is closed-toed shoes. Even though it's really warm out and it feels really nice outside, we're going to take some safety precautions while we're working through this. Okay. So you can see, thing of sugar. All right, this is just sand. I'm going to take our lighter fluid and I'm going to coat the top of that. Okay. And actually the thing that limits how big our sugar snake can get is actually just how long it burns. There's almost always leftover sugar and baking soda. But if we use a lot of lighter fluid, then it will be able to burn for longer. Okay. I tried this earlier today and it actually didn't work, which is regular grill lighter fluid. This is the kind of lighter fluid that would go in, say, like a Zippo lighter or any reusable lighter. Okay. So I'm going to put that one there. I'm going to do the same thing over here. Hopefully the wind that's going on isn't going to be too disruptive to the process. Okay. I'm going to center that just a little bit more. Okay. So now that we have that, I have our sugar mixtures. I have our sugar mixtures. This is going to be our regular. I have 20 grams of regular sucrose in here and 5 grams of baking soda. And so I'm going to put that right just in a pile. Just in a pile in the center there. Okay. I'm going to do that same thing with the powdered sugar. Whoops, I spilled a little dirt in there. The powdered sugar is just going to go in a pile there again. I think they use powdered sugar because it has a little bit more surface area. The grains of sugar are a lot smaller. So we'll see how, if in at all, those work differently. And when I measured out those combinations, I used an electronic balance that I borrowed from school. Just a little bit more lighter fluid before we get started. Just around the edge there for each of those. Now I'm going to put that way far away, so I accidentally don't do anything with that. I'm also going to take all of our other stuff out of the way reacting, and we'll get them started. I have a safety lighter, one with a long part here, so the flame is all the way away from me. I'm going to go ahead and light that one and that one. There we go. Now I'm going to start talking through some of the science of this in a second. Set everything a little bit further back. While those go, we're going to talk through some of the science here. Okay? So there's actually 2 chemical reactions going on, not just one. I'm going to pause here and show you guys up close what's going on with our experiments. There we go. I'm sorry, we're wobbling around here. I really need to figure out how to get a camera with a tripod. But you can see everything starting to grow there. It's just little bits right now. Just little bits right now, but hopefully soon we'll get one that will kind of grow upward. Right now it almost looks like a spider instead of a snake. It's growing outward from it. We're gonna let those grow. Set my camera back up. Okay. So over here where the sun's, my shadow is not on the whiteboard. So I have two reactions going on here. One of them is sugar breaking down to form carbon and water. Okay, so we have sucrose, which is a big molecule. It has 12 carbons, 22 hydrogens, and 11 oxygens in it. And it actually consists of a sucrose molecule and a fructose molecule. So you've probably heard of glucose before. Glucose is the sugar that's formed in plants in the process called photosynthesis. And so the energy from the sun is stored in the bonds of that glucose molecule. And all sorts of places in our body can break down glucose. But we also have something that we consume called fructose. And that is this part over here. So a sucrose molecule, table sugar, what you're used to eating, actually is both of those molecules, and then they're held together with one oxygen in the middle. Okay, so if you can see on the screen, this part of it is the glucose and this part of it is the fructose. When that is heated up, it breaks down into carbon and hydrogen. And so a lot of this black stuff that you see, the black stuff is the carbon that's breaking down. And then the water, because there's fire there, it just evaporates as water vapor and it goes out into the atmosphere. The reason that the snakes grow the way they do, though, the reason that they grow the way they do is because of the baking soda. So there's a separate reaction going on with the baking soda. And baking soda is NaHCO3. Its chemical name is called sodium bicarbonate. And sodium bicarbonate, when it's heated, breaks down into three things. It breaks down into sodium carbonate, it breaks down into water, and it breaks down into carbon dioxide, CO2. And that carbon dioxide here is the key to what helps the snake grow. That carbon dioxide, as that gas form, lifts up and it pulls the carbon with it. And that's what forms those snakes. And so that's why we get the outcome that we do with the snakes growing. There's other experiments that you can get this to go here. There's one where you use sulfuric acid, and the sulfuric acid breaks the carbon down and it creates the snake. But this is the easiest one to do at home. Now, should have really started with this, but it's very, very important that you know that anytime you're doing something with fire, you should always have a parent supervising. Okay. And not just like in the general area, the parent should be there with you doing the experiment. Anytime you're using fire, and really anytime you're using chemicals, you should always have parent supervision. You always want to make sure that you're considering safety. So I have glasses on, I have closed-toed shoes on, I have pants on, and I'm doing this in a really safe environment. So I have this reaction happening on sand, and the sand can absorb a lot of heat. And it's not going to cause it any harm. It's not going to catch on fire. I have these in clay pots, not plastic pots. Whoop, we got the wind blowing again. The fires are almost out. So, and then I also have it on top of something that's a rock. Now I have this on like a wooden platform, but it has a piece of concrete in between. And so all of those things are super important safety precautions that you want to make sure you're considering anytime you do an experiment like this. So if you're interested in something like this, it's something that you can do at home, but you want to make sure you have a parent there to supervise. Okay. A couple of other things, and I want to show you our final results. My microphone fell down at some point, so hopefully you could still hear okay. Okay. Firstly, I want to show you up close what this looks like. This is the one from the one that I did earlier. This is the bottom part. It's got like a hole in the middle, which is kind of cool. I guess that's where the gas bubble kind of formed and created a cone. It's actually really, really light. It's almost like a burnt marshmallow, which makes sense because a burnt marshmallow is burnt sugar as well, right? Marshmallows are sweet. They have a lot of sugar in them. And so it's a similar type of reaction to what's happening there. But just on the surface, it almost looks like lava rock or something that has that really like holy texture to it where all those air bubbles are forming. Okay. Now, this is cooled down enough. And this one, the one with the powdered sugar, is still on fire. But so I'm not going to pick that one up. But our other one has gone and kind of put itself out. I think I needed to use more lighter fluid in order to get everything to happen. But because there's still a lot of baking soda and sugar left on that platform. But you can see here, we've got maybe not a snake, but like a starfish almost. Oh, the starfish head broke off. We've got little pieces here. And yeah, touch this pot with fire in it. Are there any questions that I can answer from the live chat? I'm sorry, I've been kind of back here and I couldn't see the chat, but do you guys have any questions? I see how fragile are they? They're really, really fragile. I could probably take and like crush it into like lots of pieces. It breaks down pretty easily. It's almost, and then I get soot all over my hands. They're breaking when they're flying off. Yeah. I don't know if a blowtorch is necessary. Whoever said use a blowtorch next time. I don't own a blowtorch, so if I did some sort of demo for you, I would have to buy a blowtorch. Can an octopus be a serpent? No. We thought we were going to get a serpent. We ended up getting an octopus. Not sure. What other substance can you use other than sand? Anything that's going to absorb a lot of heat and still be safe. So I've seen some demonstrations where they just use like really fine gravel, but I went and bought a bag of play sand at Lowe's and it was only like $4 or $5. You can use other substances to get it to burn hot enough. So somebody asked or said, use lighter fluid that will burn hotter. The Zippo kind is the one that I thought that I could get to burn the hottest. I saw some other ones with like some different types of fuels that you could, I guess, could be used, but just regular glue or grill lighter fluid wouldn't work for me. Any other questions? There seems to be a debate on the live chat about whether Krakens are real. I don't know. Put it in a pan on the stove. I would not recommend doing this in any sort of indoor environment. Ia, go ahead and ask your question. It was Zana says it's a lit experiment, not gonna lie. I'm glad we can use that pun again. Why does it go up in a tubular shape? So I think it's kind of in a tube because you put the sugar and baking soda in a, like just naturally it kind of pours out into a circular shape. And then everything kind of moves up from where the top layer of that, to where the top layer of that goes up. So that's kind of why it forms into a tube. None of the demonstrations I've gotten, this is the best one that I've gotten that like really actually grew upward. I have not successfully gotten it to like actually make a full snake. I might need to, I think the key is just to use more lighter fluid because you have to get it to go for a really, really, really long time. The burning has to happen. So I think I might try that again and film it and see if I can post like a time lapse of it because we would be here all day if I sat and let it burn into a full snake. You have to do a time-lapse video for that. I'm not sure why it doesn't go outward. That's really interesting, but I guess it's because the carbon dioxide is less dense, and so it's directly rising, and so it goes up like that. Someone asks, what about a small camping stove that you can put outside? I still don't think a stove is going to get consistently hot enough in the way that you want it to. I don't think it's just the heat. I think the fire is necessary. But you're welcome to look around on the internet to see other people's tutorials. Again, if you are going to try this experiment, you should have adult supervision and permission to do so. But this is only like my third time doing the experiment. So there's a lot of people who have done this more times that could offer some better advice. I don't think using petroleum or gasoline would be a good idea. Again, all of the tutorials I've seen either use some sort of lighter fluid or isopropyl alcohol, but I saw one that said the isopropyl alcohol doesn't work. So, hi Rachel. Oh, we've got wind blowing on the. We've got wind blowing on it. I think the powdered sugar one is burnt out now, so I'll show you that one up close, and then we'll probably end the live stream. It seems to have burned upwards in like a tube a little bit more. You can see the fire or the wind has blown it this way. It's funny. It's almost like the wind has moved it and turned it like a wave would. I think it would have gone straight up if the wind wasn't blowing so much. Do I have a sciencey reason for the powdered sugar to be more tubey? I think because the grains of sugar are smaller. And I think because the fire's out, I'm going to put my safety goggles down. I think because the sugar is out, or the sugar's smaller pieces, I bet everything just mixes up and kind of grows more evenly. That would be my guess. So I think we're gonna end the live stream for the day. I have a huge yard. Yeah, I have a pretty big yard. Back there's going to be lots of vegetables growing. So maybe if this, our live streams go into summer, I'll show you my garden for one of it. So hopefully that little frame back there'll be snap peas growing on it in like a month or so. But I'm going to say goodbye to everyone until next Tuesday. I hope you can tune in. I've seen a lot of requests for elephant toothpaste. So hopefully I will make the elephant toothpaste demonstration happen next week. I got to do some research on that. But hopefully we'll get that to work. Until next time, guys, I'll see you. Stay safe, stay healthy, wash your hands. Wash your hands, guys. Bye.